Hi, my name's Daniel Lee. Welcome to my Priority Mailbox Final Project presentation for Data Science Essentials course. Before I get into the weeds of the actual project, I do want to give you a broad stroke overview of why I chose this. Many of us have email accounts, many more have multiple email accounts, and a lot of us use it as a de facto cloud drive, meaning that messages come in, message attachments come in, and we don't necessarily delete those emails. We save them for later. I think a use case is before using Dropbox, I used to send very, very important photos that I would take on my phone to my email. So I would, one, ensure that I could access it from anywhere, and two, it would essentially never be lost. What ends up happening though over time is uh, you get a lot of these emails and you don't actually end up reading most of them. At least in my case, I don't read most of my emails coming in, but I don't necessarily want to delete them. I want to archive them so I can possibly access later or search for certain things. And so what what I'm proposing is a priority mailbox where a model that can predict whether you're going to read or not read an email, and if you're going to read it, then with a high probability, then route those emails to a priority mailbox. So when you open your phone or your email account on the website, what would be great is that you'd go straight to your priority mailbox and you know that each one of those you're probably going to read. And if you haven't, you probably should, or that's an indication that you probably should. So with that said, let's get into the project more in depth. This is kind of outlines more specifically what I just spoke about for the last 2 minutes. Can I automate a priority inbox that filters emails I'm likely to read versus those I'm not? And if you see in my personal Gmail account, I have received over its lifespan a little over 21,000 emails. I don't ever delete emails, but I have still 14,000, almost 14,000 unopened. So that represents a lifespan open rate about 35%. In the last year, it's probably a lot less, closer to 20%. And so what we want to do is we want to train a naive-based classifier to predict whether or not I will open an email. And this is similar to the spam homework, the spam text message homework that we had in a previous class. I think this is probably a little more difficult in the sense that an email being spam or not is fairly definitive. Either comes from an unknown or suspicious source, or kind of the material inside is just completely irrelevant. In this case, most of the emails are relevant to you. Uh, Whether you've subscribed to a certain mailing list or you're getting email from your friends, whether you choose to open or not to open it is more uh, I guess subjective, a little more complex. It requires a little more kind of behavioral psychology, maybe the context of the situation, the timing of the day. For instance, if I get an email from my mother, there's an 80% chance, 90% chance that I'll open it. But the last 10% of why we don't open it could be for various reasons. Maybe it's my mood that day, or I got all the information I needed from the header, so I don't actually have to read it. Again, various reasons that are confounding variables that are very hard to kind of specifically model as compared to spam. So the first thing to do is get the data. As you can see, I didn't use my Gmail account. 22,000 emails is quite a lot, and what I've had difficulty with is a scalable way, or an automated way of extracting the information of whether a message was read or wasn't read. And I wasn't able to figure it out, at least in kind of the timeline that we had for this project. And so what I ended up having to do is having to hard code each message in my data file, whether it was read or unread. And again, 22,000 emails is much. So I used my business accounts, my business school email account, which has far less, about 4,000. And yeah, I'll get into that into the next slide in terms of preparing the data. But in case you are interested in extracting kind of your Gmail, I've listed a few sites that were helpful when I initially started gathering this data. So when you extract this data from Outlook, you get something similar to this, sans this open column. That's one that I had to add later on. A couple funny things happen, especially with, for some reason, emails that come from the Financial Times from me or Business Week. They come up as such like this, and so the columns are misaligned and not really sure uh, what's going on all over here. But I'm sure, again, there's a more elegant way to clean this via Python, but I went ahead and did manually, and there wasn't too much. It was only about 100. And as I mentioned before, I also had to hard encode all 4,000. There's a little bit over 4,000 emails. I had to hard encode um, all of these, comparing whether it was open or non-open from my Outlook. With that, let's get to the code, the meat and potatoes of the project. All right, there it is. So I did this kind of in 5 steps. The first step, which we kind of discussed a little bit and we'll continue kind of further, is collect, clean, and prepare the data from Microsoft Outlook. And then the second step is convert email into a sparse matrix of TF-IDF vectors. Third step is train the classifier. Fourth is measure kind of the accuracy of that classifier. And then 5 is try the model out with real life examples, and we'll kind of get to that. It's kind of fun to see how it all worked out. And so let's go. Okay. All right, so this is kind of just the standard packages that you'll need. This all nothing special. This all came from previous homework files. Then read in the 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 Outlook data as a data frame, and then from this point on, we're going to perform initial EDA. So just kind of taking a look at what it looks like visually always helps. So we see that kind of it looks similar to what we saw prior in the Excel document. Everything looks good as for all the data is aligned with their appropriate columns. And then we can kind of go further and see what else is going on here. Yeah. So you can see, I think the one thing to note is there's a 4,137 emails that were in our data file. And then let's do this. I think one thing interesting to note is uh, there's, as compared to my Gmail account, my Outlook business school email, it's less of a significant disparity between read and unread emails. So as of right now, the zeros represent unread emails and the 1 represents read emails. So right now, probably closer to about 60-40, 60%, 55% unread, 45% read, which makes sense because most of the emails I get from that account are have to do with school or coursework or group projects in the past. Okay, so just kind of did initial data analysis, exploratory data analysis. Everything kind of looks good. Now, kind of we did clean the data a little bit on through Excel, but we're we need to do a little bit more. And so the relevant features that we need, or the relevant variables that we need, I believe, are read, the subject, and the body. And I'll kind of get into using the other features for further improvements to the model, but that's what we use for right now. And so what I did is, because I wasn't able to figure out how to vectorize kind of multiple columns, multiple features. So I combined the subject and the body into a single column. And then also took out and then separated the independent variable with the dependent variable. So here we see that red is our y, and then text, which is what I created when I agglomerated subject. So taking a look at this, uh, I did add this kind of print. I wanted to show you that in doing so, there are 5 rows that come up with null values for the text. I think with 4,000, a sample size of 4,005 aren't really that important. I took a look at those emails. They weren't anything special. So what we did is we just dropped them from our data set. And so by doing so, we go from uh, yeah, we just drop those. We go from 4,137 rows to 4,132 rows. And the next step is using the TF-ID vectorizer. So that's going to take a little bit of time. So I printed out the shapes just to see kind of the magnitude of the data that we're dealing with. Again, we have 4,132 rows, and then the vectorizer we have about a little less than 30,000 columns. And the next thing to do is train the naive Bayes classifier. All right, that was really quick. And then let's kind of take a look at how how well it was trained or how good the accuracy is for it. So we get a AUC of 0.79, and then you can see the rock curve below it. I think it's important to note that in our spam homework, we got an AUC of close to 0.99. It was nearly perfect. And again, I explained a little bit before why this is a little more a more challenging prediction model. Again, there's a lot of contextual variables, a lot of confounding variables, a lot of things that out of our control that we can't actually collect data on that determines whether you're going to open an email or not. Your mood, the timing of the day, um, the again, maybe you got all the information you need from the header and so you don't actually open it. But I think in this case, kind of looking at the precision and recall, these are acceptable for now. And I'll kind of go into how we can make this model better later on. So I wanted to try having used this model. I just kind of wanted to try a few of the more recent emails that I've gotten and see whether or not they do work or this model does do pretty well. And so the first one I tried is, let's see, I'm getting a lot of emails recently. So this is this is one from my good friend Sarika. I actually did not read her email. I feel bad, but it was for one of the clubs, and so I'm going to mark that as unread. I didn't read it. I had to open it to get in there. So I received this email yesterday. I didn't read it. I'm probably not going to read it if it wasn't for this project. So I copied the subject and the body into this array, transformed it, and let's see if it predicts whether or not I will read it or not. And it predicts that I won't read it, so that's one win there. The next one is that I checked out was an MBA 2017 Global Business Experience. Let's see, which one was that? Yes, okay, so this is a class that I just most recently finished, and when we receive our grades, we get an email with the header assessment MBA 2017 Global Business Experience. So I almost always read these emails because I want to know what grade I got for this particular course or training. So did the same thing as previous to Sarika's, as I did with Sarika's email. And let's see. Yep, uh, came out with red as one, so it predicted that I would read it. Let's see, let's go to another one. Which one did I do for that one? Okay, this one was Latam Sundowners. Again, I did not read it in real life, and it predicts that, sorry, that was the wrong one. And it predicted that I'm not going to read it. So win there. Let's see. So the one I clicked on a little prematurely is from a mentor of mine, Ray Gakasan. He helped me get into college. He was alumni of my alumni, and in business school, he also kind of helped me with jobs and transitioning from the military. So if he sends me an email, I almost 99.99999% will read it at some point, and so we see that the model did predict that I will read the email, so that's another success. I just kind of I wanted to in the next example I wanted to try something that maybe would trip up the model. I wasn't able to find anything more recent, but I do have this friend James Scott Barrett right here. Him and I were both in the military. He was the UK military while at business school, and then I was U.S. military. And I read most of the emails that come from him, but there's sometimes he sends some emails about the military and business club that I don't read, and so it's kind of hit or miss. In this case, I didn't read it, nor was I going to read it, and so we'll see if that predicts that I won't read it. So I guess that one worked out really well. Maybe try a live example right now of one that I did read. Okay, what about something like more recent? So I got the email today from Student Association Bullet, and so usually I read these sometimes. I don't know, we'll see. We'll kind of put this in and see what it comes out with. So this one, put this in the header, okay, and then kind of copy all this in here. Sorry, it's going to take a little bit of time to make all this information flat into the single array. Oops. So bear with me a second. All right, so we fast forward this process a little bit, but finally got everything into here. So I'm not going to scroll all the way. That's pretty long. So I did open this today. Let's see. I did open this today, and let's see if yeah, let's see if this works out and predicts whether I will open it or will not. And yeah, that is another win. So at least in these 5 examples, the model works really well. And yeah, let's go back to the PowerPoint slide. That's it for the actual Python code. Future improvements, I think one in terms of the data is finding a scalable way to determine read or unread. I think that if that's very crucial, especially in terms of automating a productized version of this service. The other thing in terms of getting the model better, if my Python skills are more advanced, my machine learning, and maybe if I had a little bit more time to dedicate to this project, I think I'd add a time variant control, which allows you to either window or kind of give weighting to more recent behavior. So windowing essentially, as I understand it, is instead of kind of looking at the entire data to create a model, you take chunks of maybe a trailing 12-month period, trailing 6-month period to train a model, which gives you more, which trains it to a more recent behavior pattern instead of kind of over the course of several years. And then the last thing is also integrate priority contacts. There are contacts that, like Ray Gakasan, for me, I will always read his email. So that's kind of an easy way to predict whether or not I'm going to read it. I think the other thing too that I didn't have written down here is maybe what type of email is it? Is it a reply email from correspondence that I've already been very involved with, or is it a forward, a mass forward to many people? I think there's a lot of things there that you can put. Also, kind of the importance or sensitivity of the email, maybe a good feature to add in here. I think also, I use the naive Bayes and TF-IDF based upon kind of our spam homework, kind of experimenting with maybe deep neural nets or kind of random forests may provide kind of other
results, but I think again, if I had a little more time, I'd kind of venture out into seeing if those improvements help the model a little bit. Follow-on projects, other than kind of creating a priority mailbox, I think the other thing is unsubscribe recommendations. For me, I subscribed to Bed Bath & Beyond 5 years ago, but since I've moved away from one and I don't need the weekly coupons that they send out, and I just, to be honest, been a little too lazy to unsubscribe. But I think that would be a prime candidate for a product to say, hey, you haven't read an email from this guy in 3 years, maybe you want to unsubscribe. The other thing is automatic subfolder creation and filtering. Gmail does this a little bit with the tabs of inbox, social, and promotional. I think something more personalized based upon the type of emails you get would be more appropriate. For instance, my business school accounts, there's not much promotional, maybe a little bit of social, but not much promotional. So maybe it could divide things into coursework. The same thing with my UIS email account, coursework, correspondence directly with other classmates, tuition and fees, whatever it may be, based upon the type of emails that you get. And then the last thing is productizing this model using Lambda architecture, kind of looking at the many options that were outlaid in our final in the final lecture in terms of RESTful web services. So that is it. Thank you very much. Really appreciate it. Had an amazing time kind of learning about data science and kind of digging deeper into it, and kind of found my passion for what I want to continue to study in the computer science realm. So thank you, and yep, have a nice day.